what's going on, guys? Let's look at this problem right here. Here this question is asking find I1 and V0. Now for V0 we can make a relationship directly. Like you can see the resistor across V0 is 2 and the current passing through V0 is I2. So we know that V is equal to I times R. So we can say V0 is equal to I2 times 2, or we can just say 2I2. 2I2. And when we deal with transformers, there are two things we have to know, that V voltage and the turns are directly proportional. So we can write it as V1 over V2 is equal to N1 over N2. Now here we have to see whether it's going to be positive or negative. If both of them are here, you can see this one is plus side and this one is also plus side. If the dots are on the plus side, or if both dots are in the minus side, it's going to be positive. If one of them in the positive and if the other one is in the negative, it's going to be negative, right? So here both of them are in the same side, so it's positive. That's why I leave this one as positive. And we know that the turns ratio is given 1:2. So this is going to be 1 over 2. 1 is N1 and 2 is N2. Now from this one we can derive a relationship between V1 and V2. Therefore V1 is going to be equivalent to V1 is 2V1 is equal to V2 if you rearrange this. This is first relationship. And also we have another equation related to ideal transformer, that is this is inversely proportional to I1 is current is inversely proportional to the turns. So I1 over I2 is going to be opposite, like N2 over N1. Now here, to determine whether it's going to be positive or negative, you have to look at the current's direction. If the current is entering the node and one of the current is exiting the node, it means it's positive. If both of them are entering the node, it's negative. Or if both of them are exiting in the node, it's negative. Here one of them is entering. This I1 is going through the node, this node right here, and I2 is exiting from the node. So we can put positive here. Okay. Now from this one, this is also like N2 is 2 and N1 is 1. And if you rearrange, you will get I1 is equal to 2I2. This is another relationship. Now let's go ahead and apply KVL for the first loop, this loop right here. If I apply KVL, here we have 12 0 degree, and that's going to be negative since it's going through negative to positive. Negative plus 2I1 plus negative 2j times I1, negative 2j times I1 plus V1 is equal to 0. That's first equation. Now let's go ahead and simplify this one. Here we have 2. We can take that I1 common. If you take I1 common, this is going to be 2 minus 2j times I1 plus V1 is equal to 12 angle 0. This is the first equation. If you apply KVL for the first loop. Now let's go ahead and apply KVL to the second loop. KVL to the second loop. If you apply KVL to the second loop, this is going to become negative V2, because negative to positive, negative V2, then plus 2I2 plus minus 2j times I2, minus 2j times I2 plus 2I2. That is equal to 0. And if you simplify this one, you are going to get 2 plus 2, 4. So 4 minus 2j times 4 minus 2j times I2, that's equal to V2. Okay. Now we have derived a relationship for V2. Let's box this one. Now let's use a different color. Well, let's go and continue. Now what I'm going to do, we have made a relationship initially. I2 is equal to I1 is equal to 2I2. So if I want to make everything in one unknown variable, because we have an equation here related to I1 V1, and here we have an equation related to I2 V2. If we can bring all of them in one unknown variable, we can solve one of them. So instead of this I2, I'm going to plug this equation. I2 is equal to I1 over 2. So this is going to be 4 minus 2j times I1 divided by 2, and instead of V2 we can plug 2V1. In that way we can solve for V1. If we solve for V1, we will end up with 2 minus j, because if we divide this one by 2, this one is 4 minus 2j, divide with this one by 2, this is going to be 2 minus j, then divide by 2, because 2 minus j, this one divided by 2, and also this one divided by 2. So 2 minus j divided by 2 I1, because this one, if we one of the 2 is gone, but here we have another 2. If we bring it to this side, we have that 2 in the denominator. That's the relation between V1 and I1. Now what I'm going to do is, to get this V1, I'm going to apply in this equation here, this equation. If I apply this V1 to this equation, we can make everything in terms of I1, so we can solve for I1. Let's go ahead and do that. So I bring this equation here. This is 2 minus 2j times I1 plus, instead of V1 I put 2 minus j divided by 2 times I1, that's equal to 12 angle 0. Now to get the denominator 2, I multiply everything by 2, so we will get 4 minus 4j times I1 plus 2 minus j times I1, that's equal to 24 angle 0. Now from this one we can solve for I1. Now we can add this 2 together. This one is going to be 6 minus 5j I1 is equal to 24 angle 0, and then I1 is going to be equivalent to, if you solve for I1, you will get 3.07 angle 33.8 degree. Now we have solved for I1. Now everything else is easy, because we have a lot of relationship, and we know that V1 is equal to 2 minus j over 2 times I1. We already know I1. Plug that I1 here, and you will get V1 is equal to 3.44 13.2 degree. Now we have V1. If we have V1, we can solve for V2 easily, because V2 is 2 times V1, and if you solve for V2, you will get 6.87 angle 13.2 degree voltage. This one is also voltage, this is ampere. And we can find out the I2 using this relationship. 2 times I1 divided by 2 is equal to I2. So if you find out I2, you will get 1.54 39.8 ampere. And then if we solve for V0, V0 is equal to 2I2, and we know I2 is this one, 1.54 angle 39.8 ampere, and therefore V0 is going to be equal to 3.07 angle 39.8 degree, and this voltage, this is our V0. And that's how we do this kind of problems. I hope you guys find this video helpful. Thanks for watching. And if you are trying to learn this electromechanical system, there are a bunch of videos in my playlist. I hope you guys watch that too. Don't forget to subscribe. See you next time.